Okay, we're going to use the previous two video lectures where we talked about the sine and cosine functions and amplitude. I'm going to put those together and we're going to talk in this video lecture about graphing y equals a sine of x and y equals a cosine of x, those functions. So our objective, we want to graph functions of the form y equals a number times the sine of x and y equals a number times the cosine of x. We've learned a number of things, so let's review those because we're going to make use of them in this video lecture. We know, number one, we know the graphs of y equals a sine x and y equals a cosine x are sinusoidal. They have that curve like an ocean wave, if you will, or ocean swells. They repeat. This is called periodic. I think I used that word previously. We'll come back to that in upcoming video lectures. They have amplitudes equal to the absolute value of a. So if a is negative, the absolute value of that will give us the height of the function. And if a is negative, the graph is inverted about the center line. Okay, again, if that number in front is negative, the graph does this. What was above goes below, what was below goes above. Symmetrical about the center line or inverted. Number two, we know that from 0 to 2 pi, which we'll learn is called one period, one time around the circle is one period. We'll see more about that in upcoming video lectures, just kind of giving you some vocabulary words. So from 0 to 2 pi, the sine function has zeros, and again, zeros are where it crosses the x-axis when x is equal to 0, pi, and 2 pi. And it has maximum or minimum values at x equals pi over 2 and x equals 3 pi over 2. These are called key points. Your zeros and your maxes and your mins are called key points. Okay? Your cosine function, the zeros are at pi over 2 and 3 pi over 2, which is the exact opposite of the sine function. And your maximum or minimum values are at x equals 0, pi, and 2 pi. Again, the opposite of the sine function. And once again, these are again called key points. Okay? And we noted this on the previous two video lectures. The sine curve goes through the origin. The cosine curve does not. Okay, the general sines and cosine curves do not. The general sine curves go through the origin. The basic sine curves go through the origin. The basic cosine curves do not go through the origin. So let's graph them. This time we're going to focus on those key points. We're not going to worry about getting every possible value of the radians. We're just going to look at the key points of 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so to graph these functions, we want to use their key points. Okay, again, the key points, their zeros and their maximum or minimum values. Whoops, you didn't even see that because I had it. Those are the key points, the zeros, the maxes, and the minimums. We want to use those key points. We want to use the amplitude, and we want to use the sine of the amplitude to transform the graph of the base function. What's going to happen to the base function? So let's sketch this one. Y equals negative 40 times the cosine of x. Well, let's look at the base function. Remember, the cosine's base function goes from 1 to negative 1, and so that's our maximum and our minimum of the base cosine function. And here is going to be pi over 2. Here is pi. Here is 3 pi over 2, and here is 2 pi. Again, go around the circle, quarter circle to here, half circle, 3/4 circle, full circle going counterclockwise. And the cosine function had zeros here and here, And it looks something like this. A basic sketch. Maximum was at 0, a maximum also at 2 pi, and a minimum at pi. Okay, so there's our base cosine function. All right, y equals the cosine of x. Okay, so let's now, what is the negative 40? That's what's different. What is the negative 40? The negative 40 tells us, okay, that's the number being multiplied in front of the cosine function. It tells us, number one, the amplitude, A-M-P-L-I-T, is equal to the absolute value of negative 40. The amplitude is 40. And number two, the negative sign, okay, the negative tells us that we need to invert the graph of the cosine function. So we need to change the amplitude from 1 to 40, and we need to invert it. So let's graph y equals negative 40 cosine of x over here. Okay, and so there we go. So we're going to take into account what we know here. We need to go now, the amplitude is 40. So now we need to go from 40 to negative 40. And now notice, of course, I'm not drawing this to scale. That's okay. If I label my axes, I feel pretty good about that. I'm still looking at my key points, pi over 2, pi, 3 pi over 2, and 2 pi. We know that I have zeros at pi over 2 and 3 pi over 2. Okay, the amplitude is 40, so my amplitude is now 40, and we know that we need to invert this because we have a negative 40. So as opposed to starting at high, I'm going to start low. Okay, and I'm going to go through the 0, hit 40 at pi, come back through the 0 at 3 pi over 2, and hit negative 40 at 2 pi. So here is my amplitude of 40, okay, equals the amplitude. I'll abbreviate that AMP. Here's a center line to peak, center line to trough, center line to trough. From 0 to 2 pi is 1 period, one time around the circle, and it's inverted. You can see this one went from high to low to high. This one goes from low to high to low, so it's inverted. This trough here is a peak in this one. This half peak here and half peak here is a half trough here and a half trough here. So that gives you a sense of graphing these things just using the key points and what you know about the base function and what A represents. Let's do one more with a slight bit more complicated. Let's kind of throw a bit of a problem solving. We'll throw a bit of algebra at you. Uh-oh, he's throwing algebra at you. That's scary. Okay, find the function and graph it for a function of the form y equals a sine x that passes through the point pi over 2, negative 2. Now, as a reminder, we're using radians. Well, we don't know A. We don't know what the amplitude is, but I do know a point. So let's first use point to find A. Okay, let's first use that point to find the value of A, because then we can graph it. We know the amplitude and we know what the sine curve looks like. Okay, well, we know that when x equals pi over 2, y equals negative 2, well, here's my function, y equals a sine of x. This function has three unknowns, y, a, and x, but I know two of them, and I can substitute. So negative 2 equals a times the sine of pi over 2. Now I can solve this for a. Well, the sine of pi over 2, if you recall, it's 1. If you want to use your calculator, again, just make sure you're in radian mode. The sine of pi over 2 is 1. So this is negative 2 equals a times 1. And so a obviously equals negative 2. So this gives me the sine function we want to graph. Y equals negative 2 times the sine of x. Okay, well, let's take a look at that base function. Here is our base sine function. Remember, it goes from 1 to -1. Okay, here's my quarter circle. Here's my half circle. Here's my 3/4 circle. And here's my full circle. Pi over 2, pi, 3 pi over 2, and 2 pi. I know the sine function starts at 0. Pi over 2, it goes up to pi over 2. My zeros at pi and 2 pi. I've got a max at pi over 2 in this case. Whoops, that's kind of it does a bit more curvy than what I drew there. Let's kind of curve it up a bit better than that. Okay, kind of come up, go down. Okay, a trough down here at 3 pi over 2 and back to 2 pi. So this is my y, this is my sine of x function, which we've seen. Zeros at 0, pi, and 2 pi. A maximum at pi over 2, a minimum at 3 pi over 2. Amplitude is 1. Okay. So that's our base sine function. Let's usually know about this -2. So what does that -2 tell us? The -2 tells us 1, amplitude is equal to the absolute value of -2, which is 2. And of course, the negative tells us that we need to invert. Okay? So that's what we're looking to do when we want to graph this function here. Okay, so let's put that all together. So we're going to put these 3 things together to make the graph we're looking for. Okay, let's see here. Our amplitude is 2. So 1, 2, 1, 2. I'm trying to be reasonably precise, but I'm not using a ruler, obviously. And then, of course, our key points on the x-axis, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, the sine function goes through 0, but in this case, we're going to invert it. Okay, so we need to go down. The basic sine function went up from 0. We have to go down from 0 because we're inverting that. And then we have a 0 at pi. We then go up to a maximum height of 2 at 3 pi over 2. And we come back to our 0 at 2 pi. So this upper piece became a lower piece in the inversion. And this lower piece became an upper piece, but our key points stayed the same. It's just that our minimum and our maximum got inverted. So this is the graph of y equals -2 sine of x. And you'll recall, passes through the point pi over 2, -2. Well, let's check that. That was one of the key pieces of the problem. Well, here's the point right here. This is the point pi over 2, -2. So we met the criteria, and we did that by using this point to find what the actual sine curve equation is. So there you have it, putting together some of the pieces to have that all come together. I think we're going to get next into shifts or maybe periods, but that gives you a sense of the basic sine and cosine functions and how amplitude affects them.